welcome to solve this nice math Olympiad algebra problem. So here we have uh, k plus 3 is equals to k minus 3, and we solve this problem for all the values of k. So at first we find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. So here in the first method we find the value of k, but if you see directly into the question statement, it is not possible to find the value of k. But here we will give you a nice technique in which you can easily get the values of k. So for this, first we take a squaring on both of the sides, and this will be written as k plus 3 whole square is equals to k minus 3 whole square. And now we use here the nice algebraic formulas on both of the sides, and you know about that. If we have a plus b whole square is equals to a square plus 2 times of ab plus b square. In the same pattern, we use the formula into the right hand side is a square minus 2 times of ab plus b square. So we use both of these two formulas to the above both equations. So the left hand side of the above equation is written as k square plus 2 times of k into 3 plus 3 square is equals to k square minus 2 times of k into 3 plus 3 square. And now further in the next step we need more simplifications here, and we will get k square plus 2 times 3 becomes here 6k plus this 3 square becomes 9, and further we have this is equals to k square minus 2 times of 3 becomes here 6k plus this 3 square is also equals to 9. And now in the next step we move all the terms from right hand side to the left hand side, and we get k square plus 6k plus 9, and when we move all these terms here we get minus k square plus 6k, and this is minus 9, and this whole equation is equals to 0. And now here we need to add or subtract the like terms. You see that this is minus k square, this is plus k square are cancelled out by each other, and further we get the remaining values are 6k plus 6k becomes 12k, this plus 9 and this minus 9 are also cancelled out by each other, and we get this equation is equals to 0. And now further in the next step we need to divide both of the sides by 12 in order to get the value of k. So when we divide both of the sides by 12, this will becomes this 12 and this 12 are gone, and we get here k is equals to 0 divided by 12 is equals to 0. This shows that here we get just only one value of k, and that is equals to 0. But now in the next step we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. So for verification of this, we need to copy down given question statement here, and it is k plus 3 is equals to k minus 3. This is our given question statement, and here we substitute the above value of k on both of the sides, and we check its behavior. So when you put it here, it will becomes 0 plus 3 is equals to 0 minus 3, and here we obtain plus 3 is equals to minus 3. So you see that positive 3 is equals to negative 3. It is not a possible case. It is not possible that positive 3 is equals to negative 3, because these two values are not equal in general. So if these two values are not equal, this concludes about that the value k is equals to 0 is not satisfied our given question statement, and we call that k is equals to 0 be the extraneous root of the given equation, because it does not satisfy our given question statement. And further you see here we cannot get any other value of k which is satisfied our given question statement, so we called that This question has no solution in general. So this is the our first method in which we get the solution, and now here in the same pattern we again solve this problem for second method. So here our second method be the very straightforward or quick method. Here we quickly determine about the solution set of this problem. So in the second method, first we copy down given question statement. Here it is k plus 3 is equals to k minus 3. This is the our given question statement, and here we just quickly do the solution of this problem. Here we move the terms k from left hand side to the right hand side, and we get positive 3 is equals to k minus 3 and minus k. Further, you see that this is minus k, this is plus k are cancelled out by each other, and we get here plus 3 is equals to minus 3. So you again see that positive 3 is equals to negative 3. It is again not a possible case. It is not possible that positive 3 is equals to negative 3, because in general both of these two values are not equal. So if these two values are not equal, this concludes about that in the second method the value of k does not exist, or in other words we say that we cannot get any other value of k which is satisfied our given question statement. So this concludes about that this question has no solution in general. So this is the our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.